Guys, this is part two of the advanced CCT programming videos. In this part, what we're actually going to do is demonstrate how to add the PID loop as well as the PID preprocessor and connect all of the remaining logic in order to run the steam valve. Now, this will work for various types of outputs that you may be adding using the hybrid custom control block. And there are a few differences in this one that we will highlight in the video, but this is basically enough information to give you some of the steps involved in creating the custom block. In the first video, of course, we created the logic necessary to control the state of this logic block. Now in this video, we are actually going to be creating the logic that controls our steam valve.
Alright guys, here we are inside our program. You can remember from the previous video, this logic block here, this section here is what is actually changing the state of the program, switching the steam valves on and off. Now before we begin programming the steam valve itself, we need to add a few points. I'm going to right click up here and I'm going to add a floating value network input. This particular input is going to be our hot water supply temperature set point. The PID loop is not going to know how to control the valve if we don't have a value for it to control to. So that is one of our first steps, is of course to create the set point. I'm going to give it a unique name, something easily recognizable, hot water supply temp set point, that sort of thing. We are going to make sure that it is backnet exposed because we want to pull this into Metasys extended architecture. We are going to change our state text to degrees Fahrenheit, since that is what we will be working with. And we are going to put a default value in. And this step isn't completely necessary, but it's something that I like to do when doing this. And once I save that, I also need to create an output. We actually have to have something to tie this to. And of course we right click, add new. I'm going to click on this box here. It is going to put everything in order based upon the type of output. By clicking these two boxes here, you can see it kind of rearrange things for me, and it makes it a little bit quicker on searching. It's something I do know that I need a 0 to 10 volt output, so it kind of arranges everything to where I can find what I need a little faster. And of course here is the heat exchanger valve. I'm going to add one of those outputs there. Simply click in the box, press up to 1, I hit finish, and we have now created an output. We must tie this output to the point on the controller. Right now it's not linked to anything, so we've got to tie it to the controller. So I hit the define hardware, I click on point assignments, and here is that output point that we created. And you can see that we have a couple of analog outputs available on this particular controller. So I simply highlight that output point that we created, and I press the right arrow, and it assigns that to the first point, available point on our controller. Now then, we hit close, and we are about ready to start creating our program logic. We've created our outputs, so I'm going to go in here once again, view my logic, and this is of course the logic that controls the state. Whenever you click on the state block itself, whichever one is highlighted is the one that you are working with. Now I need to create a floating output in this area here. This is what we're going to tie that hardware output to. And I'm going to right click, I'm just going to grab it and drag it over to the right side of my screen, and I'm going to give it a simple name. I'm just going to call it %command, something easily recognizable, and I press OK. And once again, I do recommend you name these points. It makes troubleshooting much easier. Now I'm going to go in here, and this is the point that we just created in our logic block. I want to connect that to the hardware point, so I right click, make connection, and here is our output that we created just a moment ago. I highlight that, press OK. We are now connected to the hardware output through the logic points that we just created. Now we need to create some logic that is actually going to control this. Once again, here is the logic that controls the state of this. This is when I press the off block, you can see that it highlights it, and this is where everything we do in this screen is what will happen when this logic block is off. And it's the same when we have it turned on. So the first thing that I want to do whenever the system is off, I want it to close that valve. If all the conditions are not met to turn this logic block on, I want it to close the valve, so I'm simply going to put a constant value, which this constant block is of course 0, and I'm going to pull it into my display screen, and once the logic block is off, the command on that percent command output will be 0, which will have a 0 output to that steam valve, and that's exactly what we want if it's not running. Now then, we are going to start working on some of the logic itself that is actually going to run the steam valve when the system is enabled. One of the first steps that I need to do is I need to grab the appropriate logic block. In this lower panel on the left hand side of your screen, this is where you will select the various logic blocks for the type of programming you're doing. It really depends on what you're doing as far as what you're going to need with your logic blocks. I mean, there is a bunch of stuff inside this palette. I mean, this is something that will allow you to customize a program in any possible way that you could imagine. And it's a very, very, very powerful tool. And you can do mathematical calculations, some comparison, which you've seen that we've done inside this video. There are just many things that can be done. Timing, there's just miscellaneous control, and there's just so many things in here that I don't know if you would be able to go through each of them in a series of videos. It would take an entire series. What we're going to do is we're going to go to the control block, and we're going to pull over a PID preprocessor as well as a PID loop, and I want to set these two blocks fairly even for a very good reason for them starting out, and you'll see why in just a minute. You'll notice these are a couple of critical key connections that need to be made within these two. If you set them even the way that I have here, it's basically just a straight across connection. You'll understand a little bit more about the PID preprocessor and why it is used in just a few moments. But the PID preprocessor, some of the things that we're going to be doing with it is telling this the type of control that we're setting up here, and it will go ahead and configure some of the variables for us. Now, we also want to make our connections to the PID loop prior to exposing a few additional points on this, just because when we expose those points, it's going to kind of mismatch some of the connections here. It's basically straight across on these, proportional time to proportional, integral to integral, and so on. Now that we have those connected, I want to right-click and expose points. And there are a few points inside here that we are going to need additionally within this system for what we're going to be doing. And on the left-hand side, since these are input points, I just click a couple that I'm going to need here. And we'll talk a little more about those in just a minute and see if there are any others. And I'm just going to hit OK. And now we have populated a couple of additional points. You can also see that it has kind of mismatched some of the connection points that we have over here. That's why it's important to connect those first prior to exposing some additional points. On the PID loop itself, kind of the same thing. I'm going to right click, expose points, and there are a few in here that I want to grab also that we will need, including the reset tuning. That's one that is very helpful for something like this. I recommend that you have that to where you can adjust your tuning or reset your tuning if necessary. And there's a couple of others I think I forgot to add. So let's go back in here. Yes, the process range, I need to grab it. I also, let's see if there are any others. I've got the process ID. That is a very critical one. The process ID is very important to what we're doing. And I believe that that is all that I'm going to need on the PID preprocessor. So let's go back out of it. I'm going to go back in. I think there's still another one inside the PID loop itself I need to get. So I'm going to go in here again, and I am going to grab the direct acting. That's another critical point that we need. Now that we have those, we need to build some other points to make some connections here and actually start making things happen. I'm going to resize my screen just a little bit so where we can see a little bit more about what's going on. And I need to create a few more points here. I need to go to my input activities, and I'm going to pull over a floating input. And once again, we have got to there again tell this PID preprocessor what our set point is. So that's what this is going to be. It's just going to be our hot water set point. And I'm going to go grab another one, and this is going to be the actual temperature. I'll pull it out here on the screen, double click it. I'm going to just call it the hot water temperature, something that both of these are very critical in linking this to this logic inside this PID loop. It cannot know how to control if it doesn't know what its set points and actual temperatures are. So we're going to go here. I'm going to make a new connection. This is my set point that we created earlier under the network inputs. Highlight it, press OK. And here's our other one. I'm going to right click, make connection, just like I did previously. And here is the hardware input for the hot water supply temperature. I simply highlight it, press OK. Now I have connected those logic blocks to the actual hardware inputs as well as the network input. And we're going to resize our screen again. We're going to make our connections here to our PID loop. Once again, our set point is going to go directly to the PID loop. And we'll pull it over here just to make it a little cleaner. Grab our temperature and do the same. And then we're going to connect this to the process variable. This is the comparison between these two is going to be going into that PID, and then the PID will calculate where it needs to drive that output. I also need to pull over another input. This time I'm going to be pulling over an enumerated. And this particular input is what we are going to use to tell the PID preprocessor exactly what it's going to do. We're going to call this process ID. And we are going to go into our details page. I could have named it process ID in here, but I just kind of habit of naming it the other way. From this drop down tab here, I need to go down and actually select process ID under the state text. It's going to change my window here a little bit. Since this is going to be a steam valve, I need to drop this down and I need to select the appropriate configuration. Let's see, hot water supply temp, steam, and now then, when I press OK, what that does is tells that PID preprocessor exactly what we're going to be using this for. It tells it what it's going to be controlling. That way some of the things within it are going to be configured based upon the process ID. That is a very critical step. Now then, we're also going to pull over another floating input, and we are going to call this one the process range. This is just an input that the PID preprocessor is looking for. We're going to leave the value of it at 0 and simply make our connection. This is the operating range for this particular PID preprocessor. Kind of a little bit of a tongue twister there. But we're just going to leave it at 0. That's what the default value is. We're also going to bring in a Boolean point, and we're going to call this our tuning reset. This is going to be connected directly to the tuning reset on the PID loop itself. We will then be able to pull this point out and actually reset the tuning from the PID loop, which is something I do recommend you do. Occasionally it really helps systems. Sometimes that PID loop can get out of tuning just a little bit and you need to tweak it slightly to get it to work as smooth as it should. Now then, we have pulled over another Boolean point. This is going to be the direct acting. These PID loops can work either direct acting or reverse acting. You need to tell it which way this PID loop in particular needs to operate. And we'll demonstrate it a little further once we get it up to the point of simulating what we are doing. You can see here that I have a point that I did not use. I can simply expose my points again, go back into this and simply uncheck that point and it will go away. Just that simple. Now then, we have got most of the logic connected for this. Our last step is to then connect the output of the PID to the output on this logic section that we've created. Now then, that logic output is then connected to our hardware output, and so now you want to save your project and make sure that you save it. I mean, don't waste all your time doing this and then forget to save it. That's a bad thing to do. And of course you can see here that the output from that logic block is connected to the output of our controller. You will notice that some of these points here do not have any connections. They are used only within the logic block, so there was no need to create any other connections to them. What we're going to do now, we are going to run a simulation of this project. Of course, we're going to save the changes. We're going to hit simulate mode. And we're going to tell this a few things that we want it to know. We want to know our outside air temperature. We want it to know if one of our pumps is running as far as our status. And that is where you will set all of this up. We can have our set points. You can adjust set points. You can tell if you're in summer, winter mode. You can do a lot of testing in the simulation mode. Of course, when you put it in a real-world application, that is when things are really going to happen. I want you to notice, first of all, we are looking at the state. You can see it highlighted in blue, and you can see that it is commanded off. The off is highlighted green, and if I go through here and look, I can see exactly why. I do have a status on one of my pumps. That's all I need. I also have, if you can see here that we are false on a couple of these blocks, and that is why the current state of this is off. And if you'll remember earlier, once it is in the off state, it puts the command of 0 to that valve. That's exactly what we want. We do not want to open a valve if we don't have our pump running. If our system is below or above the lockout temperature, there's no need to have that steam on. So what I'm going to do here, I'm actually going to change this. I'm going to command this to winter mode. And of course, here's my review screen. I press send. You can see that it will change the state of this particular logic block. But it is not the only thing that we need. You can see here that we are still off. And the reason is because of the temperature that we have for our lockout temperature compared to the value that we enter to the outside air temperature. That is going to keep that system off. So that's a good way of testing that. Now then, I'm going to change the outside air temperature below what the lockout set point is. And once I change that, before I do that, let's resize this screen so we can actually watch this logic block flip. Now then, that will make it a little more clear to you if you actually see it flip. Go back into commands, change the value, and when I press OK, watch the right side of your screen. It's, of course, here's the window. I press send, and you will notice it go through, and you will notice momentarily there, it just switched to the on position. That is where we, of course, created the PID loop, PID preprocessor, and all of that. Now that state, all of this logic that is in here is now active under the simulation mode. Let's look a little closer and see some of the things that are happening. You can see here that the output value is increasing. If this was connected to an actual valve, it would be driving that valve open. You can see all of the values that are coming in here as far as the temperature, our set points, as well as the temperature that it is currently at, which once again, this is just a simulation. Now, I'm going to show you the direct acting and why it's important to put that in. I'm actually going to flip that. And once I flip that, look at what the output is doing. It is now going the opposite direction. Depending on your system, depending on how your control is set up, you may need a system where the output will actually go negative. It just really depends on what you're trying to do, but that is something that you will do within your logic by using the direct and reverse acting input on the PID loop. So now we're going to put that back to normal and of what it needs to be, and press OK, press send, and it is going to put it back to where we had it originally. If you just created that PID loop and did not add that particular point, it's actually going to try to go where, in a situation like this, to where it would not open that valve. So that is why we needed to create that particular point for that. And, you know, once again, our output, you can see it going up. You know, if you were to put a meter on that controller, you would see the value changing going out to the valve itself. And I want to show you another thing here. We are going to, let me resize it, bring it back over. I'm also going to change, for simulation purposes, the actual value of the temperature itself. I'm going to go in here and I'm actually going to increase what it thinks the temperature currently is and see how it reacts. Once I press OK, press the send button, you can see how that output has reacted. Now then, let's make it react a little bit faster. I'm going to go in here, change this value again, and you can see when I press the send exactly what it does. It actually starts going back down. If it thinks that the temperature is starting to get close to the set point or starts to exceed the set point, it will start backing that valve down. Now, once you get a system like this in application, it's going to require some tuning, and that's where that tuning reset comes in. You can let it run for a while and let it get a few good numbers, kind of, you know, monitor the system as far as how well that it does.
Guys, hope you liked the video. Hope that you find it useful. If you do, I would appreciate it if you would give it a thumbs up. Also, be sure to drop me any comments down below. Don't forget to subscribe, and thanks for watching.